Welcome to Get Your FRQ On. This question is from 2002, the B exam. It is question 5 and it is not calculator active. In the question stem, we are provided with a differential equation dy dx. In part A of the question, for the interval between 1 and 5, the line y equals -2 is tangent to the curve somewhere. Find the x for which y equals -2 is tangent. Determine if that point is a maximum or minimum and provide a justification. So keep in mind that because y equals -2 is a horizontal line, if it's tangent to the curve at some point, that means dy dx has to be 0 at that point. All right, so take the dy dx equation, set it equal to 0. Dy dx equals 0 implies that x is equal to 3. So the point that we're interested in is 3, -2. In order to determine if this is a maximum or a minimum, we can find the second derivative to determine concavity and use that to determine if this point is a maximum or minimum. So if I take my dy dx and I differentiate that to find d squared y dx squared, we get -1 times y minus dy dx times 3 minus x all over y squared. If I then evaluate that expression at the point 3, -2, eventually, after simplifying, I get +1/2, which is greater than 0. So at the point 3, -2, the function is concave up, which means this should be a minimum value at 3, -2. In part B of the question, we are given that y equals g of x is the particular solution for this differential equation over the interval from -2 to 8. We are given that g of 6 is equal to -4, and we are instructed to find g of x. The expectation here is that you're going to use separation of variables because there's not really many or any other methods that AB students are expected to know. So if we're going to use separation of variables, right, we take our differential equation dy dx equals 3 minus x over y, separate, multiply both sides by y, multiply both sides by dx, and then integrate both sides. If we integrate both sides, we get 1/2 y squared equals 3x minus 1/2 x squared plus a constant. Using the initial condition that g of 6 is -4, we get 1/2 of -4 squared, which is 16, equals 18 minus 1/2 of 36 plus the constant. Doing the arithmetic there and the algebra implies that the constant is equal to 8, which means that our solution to the differential equation is y equals the negative square root of 2 times 3x minus 1/2 x squared plus 8. How do we know we have the negative sign here? Keep in mind that when we take a square root, if we take the square root, we have to account for the fact that it could be positive or negative. But if I go back to the initial condition, my y coordinate that I get is supposed to be negative. If I don't have this negative sign here, I can't get -4 no matter what x I put in. So because the initial condition requires that y be negative, in this case I do need to have that negative sign in front of the square root.